So in this video, we're going to be looking at the modulus and how to graph complex numbers. The modulus will represent it with the absolute value symbol. And this is simply the square root of the real squared plus the imaginary part squared. So z, the standard form, is a plus bi, where a is the real and b is the imaginary. The modulus measures the distance between the point and the origin. So if we have, for example, a plus bi, so we'll assume here that a and b are both positive. Well, we go along the real axis, we'll go 8 units, and in the imaginary axis, we go b units. And then we see where they meet. So we draw a line up towards the bi, and so they meet at this point. Now the distance between the point and the origin is this line right here. So this forms a 90-degree angle. The horizontal distance here is a, the vertical is b, and so the distance will just be Pythagorean theorem, square root of a squared plus b squared. So now let's do a couple examples and show how this works. So we'll start off with z equals 4i. Notice here there's no real part. So we look at the modulus. We're only going to square the imaginary part, and we're going to get 4. So this means the distance between 4i and the origin is just 4. And if this looks challenging, I can add a 0 in front to show that, well, there's no real part to this. So think of it as going 0 across, and then we're going to go up 4. And so the distance between the origin and the point is clearly 4 units. Okay, let's look at a more challenging problem. Let's say we're given z is equal to 5 plus 2i. The modulus will be the square root of real squared plus imaginary squared. And so that will just be the square root of 29. Now graphing it, we're going 5 across in the real axis and then 2 in the imaginary axis. And then we'll see where they meet. So they meet at this point here. Okay, so what we found was the distance here is square root 29. Let's look at one more example. So this one involves square roots. It's all under one fraction. So you may wonder, okay, what's the real, what's the imaginary? So you may find it helpful to break this up into 2 pieces. So now hopefully it's clear what's the real, what's the imaginary. So we take the modulus, and we're going to take the real part, square it, plus the imaginary part, square it. And notice that they're the same numbers. Once you square it, they're the same. So you really have, 2 copies of these. Okay, so we have 2, and then the square is going to distribute both of these. So square root of 2 squared is 2, and then 2 squared is 4. That cancels, so it's 2 over 2, which is 1. So the distance between the origin and negative root 2 plus I square root 2 over 2 is just 1. Okay, now we're going to graph this. So I'm going to rewrite this. Okay, so this is the real axis. This is the imaginary axis. So the real part is negative. So that means we're going to the opposite side. So we'll go over here. And then we're going up root 2 over 2. And then we see, okay, where do these 2 points meet? Clearly it's over here. And so that distance is just 1.